We have had some fantastic talks today, and we are wrapping up with another great talk by Kevin Kaminski. Kevin, nice to see you. How are you? Kevin Kaminski is a threat intel engineer at ReliaQuest. He has worked in the security operations space for 7 years, has worn many different hats throughout the SOC. He has experience in analysis in many different logging platforms and specializes in threat detection, research, content development. Kevin works with companies to optimize their logging infrastructure and platforms to improve their security posture in response to threats. And today, Kevin is here with his talk, everything you always wanted to know about Linux logging, like why it's so bad, and what to do about it. So with that being said, Kevin, thank you for joining us, and I will let you take it away.
All right, thanks, appreciate it. Let me share out here. I'm having problems sharing now.
Is the share button working through Chrome? It looks like Chris from vSummit says share through Chrome if you can.
All right, I'll try to hop on there then. It was working when I tested last time, but all right, I guess I'll be back on Chrome then.
Okay, sounds good. We'll look forward to seeing you here.
Sorry.
Yep. So for those of us that might have just joined recently, we have Kevin Kaminski here. Kevin, I don't know if you can share now. It looks like you can. So I'm going to go ahead and let you go ahead and do your presentation.
All right. Thanks, everyone. Sorry for the rough start there. But yeah, so welcome to everything you wanted to know about Linux logs. So my name is Kevin. So thanks just to BSides and everyone for putting on this event. I'm really happy I got the opportunity to do this year. So all right, let's get started with it. So why did I come up with this talk about Linux logging? So I really started just with my experiences just as an analyst and doing content development, building rules out for different companies, and having to work with Linux logs. So Linux logs are, the hosts are really usually running critical applications in customer environments, but for some reason, like building out content, doing analysis, they never really seem to get a lot of good visibility into the endpoints. So it had gotten to the point where, like, whenever you see a Linux host in your analysis, you're just like, all right, going in with some very low expectations on actually finding anything. So here's just like some examples of just some different cases that I've come across, just so you know what I mean. So like, you're in the SOC, maybe, security alert comes in, search on the IP, you see some Linux logs coming up, and you see a log like this, and you're like, okay, a group was removed, and you're just like, okay, like who did it? Is there any other information about this group? Like just a name? Like where's like the rest of the context for this log? And you're like, Windows gives me all this information when I find those logs. So like, why can't I find this information? Or you have something like this where somebody modified the cron jobs, and it just says somebody replaced a line. Like what line is it? I look at Windows scheduled tasks. You get almost too much information with that. So why is there not any information in these logs? Or it might just be straight up that there's just no activity that you're looking for. You get the IP address of the box, you're going to search on it, and then you just see like a wall of just cron jobs running and really nothing going on. So you're just like, why is there no activity? Like, I know somebody's on this box, like why can't I see anything? And I'd actually done a talk last year on logging failures and went over a Linux scenario. And Linux, the default logging is not really set up to catch a lot of this really detailed information, unfortunately. So I'm just gonna, during this talk, I'm just gonna like kind of take you through my journey that I went through to figure out what is going on with Linux logging and how it can be improved, and some of the questions that I had. I'd also like to say that this is coming from someone who's not a Linux admin, so I'm not certified. So if anything's wrong or it's too simplified or anything, I'm sure people will let me know. So some of the questions I had, going into this was, what does syslog even mean? How do you actually create syslogs? How do programs actually do that? Why is the format just honestly so bad? What does sending syslog mean? And then if it's not that great, then what are the alternatives that we can look for? So in the beginning, we had syslog, but what is it though? So, is it a server? You might hear the term like syslog server, it's where you send all the logs to. So is it that? Is it a protocol? Because, you got port 514, you're sending syslog, as a network protocol. Is it a format? Because people talk about things being sent like in syslog, logging syslog. Is it a service though? Is it, the syslog service is running, something like that? So the answer to all that is yes. If you actually go into the syslog RFC, it defines these different layers of what syslog is. It can be content referring to actually what's in the message. It can be the application. So you have like the programs generating syslog or the syslog daemons actually storing it and routing it. Or you have the transport of actually sending it over the network and applications receiving it and processing it from there. So it's actually all of it, which kind of just makes it more confusing. In terms of like the history of it, it was created back in 1981, originally for the BSD distro. It was widely adopted into all different technologies, not just the Unix systems, but also like networking equipment. Lots of other things use it. The first daemon was created in 1986, and then it was actually only standardized in 2001. So it took like 20 years to actually standardize it. And in that RFC, I think it's pretty funny. When the intro, they get really philosophical about how like syslog is the natural evolution of communication since the beginning of time, or something like that. It's pretty funny to look into that. And then finally in 2009, there was a revised standard, which we'll go dive into those in a sec too. So that's what it is. So how does syslog actually get generated from a program? So it all starts with the function calls to actually start beginning to log that. So you have open log, which actually isn't required, but you pass it the name of the program. You got some options that I'm not really going to go into, and then you pass it the facility. So this might look a little bit familiar. Kind of just, it's really just a tag for the log that labels it for what type of application is sending it, which is going to be more important a little bit later. So OpenLog prepares the connection, kind of customizes it a bit. And then you have the actual syslog function, which is going to actually send the message to syslog. So this one's actually required. If you don't use OpenLog, it kind of just fills in these default values. And the first argument you have is the priority. So this should look pretty familiar. It's like the default levels that you see all over the place for logging, emergency, info, debug. So you send it what the priority is of this log, and then you kind of just put whatever you want in the log. It's just this open string. You can put some formatted arguments on the end, but really it's a wide open argument there. And looking at an actual example program, so this is the add user program, and you can see it's calling syslog there, setting it as info, and that's the actual message that you normally see in the Linux logs: add user to group. Just calling those usernames and group functions. So I was asking myself, like, who determines what goes into that string? Like, why? Like, they're actually defining it there. And yeah, it's really just whoever wrote it and whatever they felt like putting in the log. So that's kind of one of the issues with how Linux is so like decentralized across all these different packages and services, that there's no really standardized standard for this logging, and people can kind of just put in whatever they want, even though there's RFCs. So there's no real enforcement. So getting into the actual format, you have what's called the BSD old format, which is like the original one. It was documented in RFC 3164, which it wasn't standardized, it was documented. So they were kind of just like observing syslog in the wild, what people were doing with it, and then just documented like there were some like Safari researchers or something. So it's not actually a standard, it's just like what people most commonly were using. So this is what you normally see. And it starts with the priority value, which is the facility value from earlier, times 8, plus the priority value, like using the IDs. So in case you ever wanted to know what that was, you're welcome. And Then you got the timestamp, which doesn't have a year, which I never noticed before, but that seems like a pretty obvious shortcoming there. And then you have the tag, which is the actual, usually the process name from the function calls that's going to be actually logging it. Sometimes it has a process ID in the brackets, sometimes it doesn't. And then you just have this unstructured string where you can just put anything you want. So, but there was a new version that got standardized. So what's different about this one? So there was an actual standard put out, not just the observations. And so this is what it looks like. And if you've ever seen it before, you can usually recognize it with those 3 dashes in the middle, as that's what the new format is. It honestly doesn't change too much. You have the version, which is basically always 1 at the beginning. The timestamp's actually a full-blown timestamp this time. The process name is the same. It's got a separate field for the process ID. You also have some extra identifiers like TCP or like firewall connection stuff. And then you just have, the same unstructured message. So it doesn't really change that much. But if you look closely, boom, you got structured data in here. There's a field for actually structured data. And it has like an example where you can actually put key value pairs in there. And look, you got like the event ID field and like, the event source, stuff you're normally seeing from actual like other logs like Windows. So this is so great. So like, you're probably asking like, why haven't you ever seen any structured data before? And then you kind of realize that's because nobody just bothered to use it. And the people who make the programs just were like, yeah, I'm just going to keep doing the same thing and not deal with that. So it's like, it could have been really cool, but nobody decided to adopt it. So it's really great. Then putting it all together, how does Syslog actually get sent and stored different places? So it all starts here with the program. So the program generates a log file, and then it's going to call the syslog function, and it's going to write it out to devlog, which devlog it's not a file, it's a socket. So if you try to cat it out, you're not going to be able to see anything. You actually need to connect to it to pull the messages from it. So you got all these programs dumping these messages into the devlog. And then you have, to read it, you have what's called the syslog daemons. And so these, you got your syslog D, rsyslog, syslog ng. Syslog D is the first one, but it's pretty much been replaced by these other two with more advanced features, and you might be more familiar with those. So those are sitting there, and those are going to read the log message out of the socket, and then they have to determine what to do with it. So they have the syslog configuration file, which if we open that up, it has the different configurations for what to do with it. So this is where the facility and the priority come back into play. So you basically have the first part of the line, like you have auth.warning. So it's like auth facility, the warning level of the priority, and then it tells you what to do with it. So it's going to write it out to varlog auth.log. And you can kind of go through that and filter on those different messages. You can use wildcards, multiple ones, and determine where it's going to go. And then finally, you can also send it to remote servers as well. So here you can write it to any messages you want or any locations. You can send it to any servers, and then there's sometimes other features where you can do different things with it, or you can send it to different locations. So that's really the full-blown pipeline of how Syslog gets to where it goes, starting with the program. So this is kind of considered the traditional method of collecting Syslog, where you have devlog socket with Syslog daemons pulling it out and sending it. But there's also some other options that are out there. So you have systemd, which some people might be familiar with. It's kind of this suite of management services that you can use systemd to like restart services or turn them off, turn them on. So one of the things in the suite is this systemd journald, which is going to basically read the logs the same way from the devlog, but it can also, for the services it's managing, it can also log the system out and system or standard out and standard error from each service. So you get some more context into what's actually going on inside the service. And all that it's not written out to varlog, it's stored in this file called the journal, which is this binary file that you can read with this journal CTL utility. And so this is what one of the logs looks like, which it looks really cool. It looks nice. Like there's all these fields in here. Everything's the key value pair everything's matching up. This is for an SSH login, so you can see the line there, but all this additional context is given. So it's really nice. It's like, why doesn't everybody just use this thing? Moving the pros for it, you have, like I said, you have the more organized file. It's easier to search out and it logs more things. But one of the problems, you can only read the logs using that journal CTL command. You can't cat it out. It's a binary file, so that's like the only way it can actually get out of there. You can't filter the logs before they get stored, so it doesn't have the rules like the Syslog Damien where the stuff goes in the socket and then it's just, it only pulls out what it needs. Everything goes into the journal, so it can kind of get pretty big and actually, take up a lot of space if you just leave it running. It can't actually just send anything by itself, so you need a separate service called journal upload to send it. Or the other more modern Syslog daemons can actually just read from the journal themselves and send it. But then, you're installing two Syslog programs, which can be kind of redundant. And then the SIMs also, because it's a whole different log format and you have to connect in to the journal to get it. Sometimes SIMs require completely different connectors to handle it, which is just a whole different process from the regular, easy to just shoot syslog at a server. So it's it's a little step forward with the logging level, but it has some more drawbacks. Then you have also other programs that kind of fall under supervisors. So you have like daemon tools. There's something called like S6. There's a lot of different these Linux packages. And what they do is they supervise every service with the logging by having like a separate process for each service that just collects logs from that service. So it attaches it to like all these different services running and just collects the standard out or the standard out and error from those services. And you can also get the devlog syslog, so you're not missing that as well. So it's kind of nice because you can customize the logging process for each service to pull different things. So it's a little bit more flexible per service. So like if SSHD, you want to get like more info from that versus other ones. It's more redundant. So with syslog daemons, if that process goes down, syslog logging stops. But here each service has its own logger, so it's a lot more redundant if anything goes down. And then it also can get the additional logging there. And if you go on the S6 website, this guy has his own pros and cons for why you should pick it. He basically goes on this rant where he's just like, syslog sucks. He's like, I'm not being judgmental, just stating the obvious. Use S6. Don't even use syslog. It does nothing special. Don't even use it. And even from reading the other supervisor websites, they all kind of have a similar sentiment where there's a lot of hate for syslog, and they kind of go on these little rants, which I found funny. Cons for this though, because you have so many different processes running across there, standardization might be kind of hard if you're customizing your logging for each individual service. It might get a little bit too much, and also to just manage all those different logging processes for all the different services. And again, it doesn't have any sending capability, so you're just going to have to use another syslog daemon or something else to get the logs from it. So overall for syslog, it's been used for a long time, but it's not, it's got some flaws. So the big one here is that the scope is really limited to the services logs. So you're not getting people running commands, you're not getting files being modified, you're not getting processes starting. It's really just whatever is logging out of those different service programs, like the authentication ones or cron, and whatever they decide to do it. The activity is pretty inconsistent because again, people are writing these different tools and services, and there's no real standard on what should be logged. So a lot of times, activity is going to be missed. Again, it's up to the people. They might leave out, critical information that you would find really useful. Data is really unstructured. Sometimes it's just like really long sentences for the syslog, so it makes it really hard to actually parse that. And then the documentation is also not really that great for what is actually generated. So Windows, really good documentation. Here's all the event IDs. Here's the log format. Here's everything. For the different syslog applications and stuff, there's nothing really there. I mean, I was going to the code to find like what the messages were. So, I mean, overall, it's not a really good state for what syslog is there, and it's default, and it's from what we see, most companies out there are just using the default syslog. So it's really, there's lots of gaps out there. But what can actually be done about that, though? The answer is enhanced logging, which we need to go to some additional tools like using Audit D, using OS Query, or ideally doing some EDR detection with some other tools like Carbon Black or CrowdStrike, and getting some additional visibility that way. So I was going to go into each one and kind of see what it offers, the pros and cons of each one, and what's ideally should everybody be using. So Audit D is part of the Linux auditing system that's actually built into the Linux kernel. So for a lot of distros, Audit D is already installed. So that makes it pretty easy right off the bat. It can log process activity, file activity, and some user commands. So it's also pretty good. It does everything based on syscalls to the kernel. So that's how it's going to be logging all these different activities. And so syscalls are not the same thing as the shell commands. So if you type in, ls or something like that, it's probably not going to show up as an actual syscall that needs to go to the kernel. So these are some examples of some commands that actually have associated syscalls. So you can see like kill, making directories, getting the time, things like that will actually be called back to the kernel where they can be logged. The big one here is the execv, which is what is used to generate a new process and start a new process. So that's really going to be the core of monitoring for new processes with using Audit D. So overall, how Audit D works, again, it works by intercepting syscalls as they go to the kernel. So you have this application, it wants to start a new process, and it's going to go through these 3 filters, this user task and exit filter, and they basically have criteria where if the syslog or the syscall matches it, then it's going to get logged back to Audit D. So if it matches it, it goes to this whitelist filter, and then it sends the details of that syscall back to Audit D. So how do you define the rules that are going to be in these filters to intercept these syscalls? So it's all defined in the audit.rules file inside Audit D. One example, if you wanted to monitor for a file, you just drop in this command in the file, and then you're good to go. So you start with W just put a watch on this file. We're looking at the etc password file. That's going to be the file path. These are the different actions that you can monitor for, read, write, executes, or just changing attributes of the file. And then you can give it this little helpful tag, which will label the log for what you were trying to monitor for. So this is an example of what one of those logs would look like with Audit D. You can see that even though we're monitoring files, it's still a type syscall at the beginning because it's still intercepting the syscalls. But you get some useful information out of it. You get the user IDs, you get what program was trying to access the file. You'll notice that the key is what the tag was, and nowhere else in the log does it say what the file was that was being modified. So that's why you kind of want to put it in the tag so you can at least know what was being modified there. So overall, that's not too bad for file monitoring. Process monitoring, this is the line you would put in the rules file for this. It starts with, you want to put in the action, which is like always or never. So you just always want to log things. Just makes sense. And then the next one is the filter that you're going to actually put the rule in. So most of the time it's the exit filter when the syscall is exiting. Then you put in the name of the syscall that you want to intercept and get the details from. So here, if we want to monitor for just process creation, we're going to look at the exe syscall. But if you want to make a rule looking for like syscalls when people check the time or make directories, you can put that name there. And then here it also has an optional file path where we can look for specific files that we want to monitor if they're executing. So here, every time SSHD executes, we're going to get a log for that. So you might be wondering with this rule, this is just looking at SSHD, but what if I just want to monitor, all the processes that are running, like you can in other tools, or like with Windows, like 4688 or something. I just want to see when it runs, and I just want to get rid of this. So the problem with that is you are going to get destroyed with an insane amount of logs from all kinds of processes. There's so many things running. It's so infeasible to just blanket throw that out there, and your system and network will just be consumed with these logs. So that's not the best idea. What you want to do is what was on the previous slide, where you want to filter it down to what specific services and files you want to monitor that are being executed, which unfortunately, there's so many services and so many things out there that you can't make a rule for every single one. So unfortunately, you're going to have to pick, some key ones that you want to monitor for. And since you're essentially just looking for a file, if it's executing, you can actually just rewrite this as a file watch to make it a bit easier, and just using that X parameter to look for when that's executing. So looking at the logs, even with this, the logs aren't really the best either. So you notice it's split into two. So you have one with the syscall, which has the user and the process, and then split off from that is the actual parameters and arguments that were actually put into, that syscall. So it kind of makes it difficult to do investigations where you just want to look at, oh, this process fired, what was the command line arguments that were put in? It's separated, it's linked with this ID, but it can be kind of hard to do that for investigations, and especially for building rules that are trying to you're going to have to correlate two events together with that. And then further, if you look at the exe event, the command line, it's split into different arguments as like separate fields. So you're not actually getting the full command line that somebody put into a program and ran. It's breaking it apart. So it's actually even harder to build content around that. If you're trying to look for specific patterns or regexes for specific commands being run. And then another thing is that it also is only going to give you the arguments for the syscall. So let's say you have a user or an attacker is on a Linux box, and they put in a huge bunch of piped commands, maybe making some named pipes or something like that. And it's only going to log when a syscall is actually called from that. And it's only going to log the arguments for that individual syscall. So if you pipe 5 commands together and they're all using syscall, you're going to get 5 separate logs with the little chunk of the command line in each one. So it's kind of hard to see really what people are doing on the box with the command line. So review on Audit D, it's good because you can get visibility around processes and file activity that you can't get with syscall or with syslog. It's pretty easy to configure. You're just dropping those rules in there. It's free. It's usually installed by default. You get the real-time monitoring from directly intercepting those syscalls. And the file format is pretty structured, so it's easy to parse out and build rules around. The problems is that if you have a ton of rules, since it's actually has to pass those filters when you're running a syscall, it can actually slow down the performance of the system because it has to, put all the syscalls through all those filters. So you put too many rules in there, it can kind of degrade that performance. Again, it only logs when a syscall is used, not just when any command is run. You can't log all the syscalls. It's way too noisy. You have to look at specific files. But if the files actually change, like the file path or anything else about it, then it's not going to be useful anymore. The command lines are separated out from that syscall event. The arguments are broken out, and then, it doesn't actually show the entire shell command. So overall, it gives us some more visibility, but there's still, some more issues when it's going to come to investigations and integrations, and there's still some gaps there. So next, let's talk about OS Query. So OS Query is another great tool. It was made by Facebook and released open source in 2014. So you don't have to worry there's no ads or tracking or anything. It's actually a pretty awesome tool. And what it does is it stores system info in a database, and it's called OS Query. So you're basically querying the operating system for this information. So it's a different way of doing the logging. It uses SQLite syntax with this other utility that you can use to actually just run queries against the system. So let's say if you wanted to get the uptime of the system, you can query the uptime table in OS Query, and it'll spit back, all these results. Or if you want to get the bash history for all the users, you can, query the user table and join that with the shell history table to get, what the user was doing, and or who the user is, and then what their activity was. So it's pretty cool. How the architecture is laid out. So OS Query, you have your SQLite engine on top of it, and it's going to get data from 2 different places. You have virtual tables and then event tables. So virtual tables aren't actually really physical tables. What it does is when you query a virtual table, it basically runs a command on the back end that pulls the data back for you dynamically. So one thing it can do is just call different functions. So when you run a query against that uptime table, it actually just runs this function in the background to pull the current uptime for you. So it's not actually like storing it anywhere. And there's all kinds of other like APIs and other files that OS Query can just dynamically pull the latest data from you without, it's not really querying a database, but it looks like it is. So when you query for the shell history, it's actually just reading the bash history file. It's not actually in a database or constantly logging that. Then on the other side, you have event tables, which is actually, it actually uses a database on the back end to store this information over time. So one of the data inputs is the syscall monitoring. It uses the same framework that Audit D does. So you get all the same syscall information going into these tables, the same type of file watch capability. And then you can also tap into different sockets. So you can go back to the devlog socket and read traditional syslog into the event table. So you kind of get everything all in one. Then you also have the OS Query daemon, which is going to use the SQLite engine, and to actually log it out, it's basically going to run these queries and then write out the results to the varlog OS Query files. So that's how the logging actually works for that. It's kind of like Splunk, where you need to schedule the queries to run and pull data, and then only log out the results that you want. So in terms of what the queries are, how to schedule them, you have this query file, which is going to have all the different scheduled queries. So it's all in JSON. So you go to the schedule key and you just drop in a new entry for here's the query you want to run, and here's the interval you want to run it on, and then it will write out those results to that file. So for file monitoring, you can just do a join of the users with the file events table, and you have to configure the file watches before by putting the actual files you want to watch into this file path key in the same file. Otherwise, the whole table will just be blank. For process monitoring, so you have to configure this a little bit before, but in the process events table, that's where all the syscall information is going to be. Then command history, again, you can just look at the shell history table, which is pulling from the bash history file, which to pull the bash history, it doesn't log timestamps in bash history by default. So you want to set this time format variable in order to get those timestamps. Otherwise, you're not going to know when anything actually happened in the logs. And just looking at some of the logs, overall, it's not too bad. So this one, file got modified. You have the action of what happened, the user that did it, the file that got modified, a bunch of IDs, lots of other information, file hash. So it's pretty good. It gives a lot of detailed information. And then process monitoring, you can see it's actually one log. It's not two of them like Audit D. So it actually does that join for you. So you can get the command line and the file and the user and the syscall all in one event. So it's really nice, really a lot better than Audit D. And then finally, you have the command history, which is basically just reading the bash file. So it just kind of puts the columns as whatever's in the bash history file. But still pretty nice. So OS Query, so in review, it can log the process of the files, the command activity, and a lot more stuff. I didn't really touch on like a lot of the other operating system data you can get out of it. It can plug into all sorts of different sockets, different APIs and things. So it's really, really robust tool. It's pretty easy to install. It's free, open source, and you can really filter down to exactly what you want to be written out to the log. So you don't have to blow up the log file with everything that's happening. You can specifically, query the syscall table and pluck out the different syscalls you want. You don't have to just log everything like with Audit D. And the logs are really structured and provide lots of detailed information. So it's really good for building content and doing analysis. The downsides to OS Query, again, you got to have to watch your queries because it can degrade performance if they're really inefficient or running too frequently. So you kind of have to manage it like how you will like with Splunk, making sure that you don't have too many of them all running, at the same time or querying just a ton of data. The queries are not real time, so depending on how frequently you're running it, you might miss out on some actionable time. The one thing, though, is you're going to have overhead developing your own queries. So OS Query comes with a lot of default packages that can detect lots of different activities, auto-log things for you. But if you want anything specific or you want to try to tune down that, you're going to have to go in and make or tune your own queries. So that's just some more time and work to put into it. Since the process monitoring uses the Linux auditing framework, it has all the same problems that AuditD does with the processes, where the syscalls aren't actually going to account for all the activity on the actual machine. It's only going to log when those are generated. And the final kind of big one is the bash history file. That's where you get all the commands from. But that file is really unreliable. If you just wipe the file, then nothing's going to come back. You can easily bypass. There's lots of different ways to like make sure your activity is not logged in that file. So that's not really an accurate read of what's going on the machine. So we finally come to the last one, EDR, which is really the ultimate solution if you want to get lots of visibility on your endpoints. In terms of what they are, so they're really enterprise-grade technologies where you deploy agents to all your endpoints that are going to collect all the local information. I think Carbon Black even uses OS Query to collect some of that information, but you get lots of granular information from all those endpoints, and it sends it all back to this nice interface where you can see all the process trees. It's got all the command lines for each processes. There's tons of data. You can search it. It's really robust tool for really knowing exactly what is executing and going on the machine. So it can log all the same stuff that AuditD and OS Query can in terms of file and process activity, but it goes a step beyond that as well. So you get all the processes, not just the syscalls. So you get everything, all the commands the user executing, all the processes running. You get full process command line, so it's not going to be chunked up into different arguments. It can log the network connections that the different processes are making, any modules they're loading, memories getting accessed. So really, it's really the complete tool for getting complete visibility on the endpoint. It really does a lot of good stuff. It also has built-in alerting capabilities, so you can build custom rules to detect different types of processes or different types of activity, which is really nice. So you don't have to forward all of the raw process logs to your SIM and just blow out your license. You can manage everything inside the EDR tool and then send any relevant activity onto the SIM. Also has built-in threat intelligence, so it'll automatically flag things with different malicious file hashes or going to malicious IPs. Then you can also automate lots of actions out of it. So you can remotely isolate hosts, delete, stop files from executing, remotely log into the boxes and do investigations that way as well. So really, EDR is really the ultimate solution for this, but why doesn't everybody have one then? So in terms of all the pros, kind of already talked about those. So it's really expensive is the problem. AuditD, OS Query, free tools, Syslog, free tools. EDR can be pretty costly. So, not everybody can actually afford to use it, although it really is a good tool recommended to get if your enterprise is big enough. You bring on additional overhead to actually manage all the servers and agents now. So you're going to have basically somebody just working to make sure all these agents are working properly and tuning them down and just maintaining the uptime for all of those, rolling out new updates. So it introduces a lot of new work. Then there's just overhead developing queries. So a lot of the default rules and alerts that come packaged leave lots of gaps. With the endpoint, you can build hundreds of rules and still have gaps, but you're going to have to do a lot of work to fill those in yourself by developing your own queries if you really want to get good visibility and you're not forwarding all the logs to the SIM. All the code isn't open source, so from using lots of different EDR tools, and a lot of them have bugs. There's lots of different problems with them. New updates might come out that will introduce new things or break features, and there's really nothing you can do about it. You just got to open a vendor ticket and just wait for them to help you out. And then finally, the query languages themselves that these tools have can be a bit limiting sometimes. You might not be able to do certain things like using regex patterns or looking at certain parents of parents of parents of processes. So it can kind of make some of the content not even possible and make investigations a little bit harder and more time consuming. But overall, EDR is a really, really good solution for endpoint logging. So in the conclusion, so Linux logging, really important for any organization, especially if you're using Linux. The native syslog is pretty good in terms of just having any visibility. That's the first step. but it leaves some pretty huge gaps for what's actually going on the endpoints. The alternatives to the traditional Syslog aren't really that much better necessarily. And really you need enhanced logging to get the full visibility there. So looking at Audit D or OS Query, can give you some more visibility into the process and file activity. And then EDR is really the best option if you want to see everything going on, but it can be pretty pricey. So overall, what I'd recommend is the best coverage is really having the native Syslog, and you want some enhanced logging, because the thing with the EDR tools is they're not going to get the regular Syslog logs, which are from the actual applications and services running. So like adding users, deleting groups, things like that. So that stuff can be useful, and the process and file monitoring can also be useful. So having both of them is pretty good. Is probably the best solution there. And here's just, I broke down this chart, just throwing out all the different technologies that I've been talking about based on the different attributes. So you guys can just take a look at that. It'll be in the slides. And yeah, that's the end of my talk. So again, thanks for having me. And yeah, hope you learned a lot about Syslog and what you can do about it.
Kevin, thank you so much. This was a fantastic talk, very informative. I'm going to open it up so that we can have our room monitor go over the questions that were asked.
Do you want me to go down the questions? Oh, okay.
You select. Hear me?
Yep.
I'm sorry. Did you hear the question, or should I repeat it?
Oh yeah, I didn't hear anything.
With the Android being Linux-based, is there any known tools or methods used to collect their system logs? That's the first question.
I haven't looked into logging Android. I mean, because it's Linux-based, I'd imagine there's probably some similarities there, but yeah, I haven't looked into to doing that with Android.
Okay, the second question is, because of sudo, sudo, is it difficult to know which user ran a command/system call?
Yeah, it can kind of obfuscate that a little bit. The sudo logs themselves are actually pretty good because it does give you the command that was run. I'm not sure if it gives you the actual user that was doing the sudoing. But yeah, I mean, if you're switching around users and doing things as root, yeah, it can definitely obfuscate that a bit. You'd probably need like EDR tools to really trace back the history of that process tree to figure out where it came from, which, yeah, isn't going to be something that you'd probably get from the other tools.
Okay, thanks. That's the only questions. Does anybody else have any questions? Please put them in the question and answer section. Are you monitoring the chat session at all?
Yeah, I'm looking at the Q&A that are coming in.
Yeah, looks like a couple more popped in just now. Are there any Kali tools that do this? It was a follow-up, I guess.
I guess is that referring to doing logging in a different way? I mean, I was using actually Kali for some of this and just like installing the tools on it. I don't know. I guess what else that'd be referring to.
Okay, we have another follow-up one regarding EDRs. Would I stay with that? My employer already has other technology with already integrated them better, I think is how you wrote it. I'm not sure. Yeah.
Technology already integrated them better.
Can you? Oh yeah. Okay, you're reading it.
Yeah. I mean, I think EDR is always like the best option. I don't know if you're saying they're trying to switch to like one of the non-EDR tools,
right?
or changing EDR products. The EDR products are kind of like, I don't know, they kind of all have very similar functionality. Okay. Oh, okay, like staying in the same suite of the vendor or going outside of it. Honestly, we see like from lots of different customers, we see people have a huge mix of tools. From a just from like a logging detection perspective, really whatever one has the best features. There's not really a problem mixing the technologies. From like a detection perspective, it might be a little bit easier if they kind of like have some synergy where they can kind of work together, or if it's a little bit easier to maintain for the guys on like actually doing the engineering work. That'd probably be the only overhead. From a detection side, we see customers with all sorts of mixed suites of tools. So it's really, you don't really have to stay in there if there's a better one in a different vendor. And then going back, there was a question for the Kali tools for log analysis. I'm not too sure. I haven't experimented too much with the log analysis tools in Kali, so.
I think that's it, Rufaro. Thank you, Kevin, for that very good presentation.
All right. Thanks, everyone.
Perfect. Thank you so much, Kevin. We really appreciate this very informative talk. And with that being said, I think this session is completed if no one has any more questions.
All right. Thanks again.
Thank you.